Hello students, I am Dr. Ashish Vikhar and I would like to welcome you all to this very important lecture. And topic of today's lecture is how to prepare heat balance sheet. What is heat balance sheet? Which is our topic number 2.1 of unit number 2 of the subject power engineering and refrigeration. Before proceeding to the lecture, I would like to appeal you that to subscribe my YouTube channel. My YouTube channel name is Knowledge Link by Dr. Ashish Vikhar. So let us start to understand what is the meaning of heat balance sheet and how to solve the numerical on heat balance sheet. As you can see in this picture, we need a heat in the form of energy to run the internal combustion engine, and this total heat provided Q to the internal combustion engine is used in various ways. This heat is sometimes lost in cooling water. This heat energy is utilized to produce brake power. This heat is utilized or it is lost in exhaust gases, and some heat which is provided to the internal combustion is called as a unaccounted heat. So how we have to make the balance sheet of this heat, that we are going to learn in this lecture. So as you can see, some percentage of heat is utilized in cooling water or loss in cooling water. Some heat is utilized in producing brake power. Some heat is lost, some percentage of heat is lost in exhaust gases. So how is the structure of heat balance sheet, that we will understand. What is heat balance sheet? A heat balance sheet is an account of heat supplied and heat utilized in various ways in the system or internal combustion engine. Here is a structure of heat balance sheet. On the left hand side you will see that heat supplied by the combustion fuel, that is represented by the symbol Q, and the percentage is written here 100%. And how is the expenditure of this heat per minute, that is given in the right hand side. Heat produced in heat that is utilized in producing brake power, that we have to determine. Heat carried by jacket cooling water, how much heat is carried by exhaust gases, and how much is unaccounted heat. These values in the form of percentage that we have to determine, and this is the structure of heat balance sheet. The results of the such type of calculations are tabulated in the table, and this table is known as heat balance sheet. The heat balance sheet is generally done on a second basis or minute basis or an hourly basis. So what are the uses of heat balance sheet? The use of heat balance sheet is as follows. Number one is to know an account of heat supplied and heat distributed in various ways in the system, to analyze the performance of the engine. So these are the two main uses of heat balance sheet. So if a question comes in the exam, state the use of heat balance sheet, then you have to write these two important uses. One is to know an account of heat supplied and to analyze the performance of the engine. Let us understand how to solve a numerical on heat balance sheet. One example or one numerical we have to solve in the exam minimum, and how to get a solution of such type of preparation of heat balance sheet, that we are going to learn. What is the problem? An IC engine uses 6 kg fuel having calorific value 44,000 kilojoule per kg in 1 hour. The brake power developed is 18 kilowatt. The temperature of 11.5 kg of cooling water found to rise through 25 degrees centigrade per minute. The temperature of 4.2 kg of exhaust gas with a specific heat 1 kilojoule per kg K was found to rise through 220 degrees centigrade. What has been asked over here? Draw heat balance sheet for the engine. After reading the problem statement, let us start to solve this problem first. What is given in the problem? Mass of the fuel, that is equal to 6 kg per hour. So it is in the kg per hour, we have to convert it into kg per minute. So 6 divided by 60 is equal to 0.1 kg per minute. Second one, the calorific value of the fuel is given 44,000 kilojoule per kg. This is a calorific value given in the problem. Brake power produced is 18 kilowatt. Mass of cooling water that is given in the problem is 11.5 kg per minute. And temperature rise of cooling water delta TW is nothing but given in the problem is 25 degrees centigrade. So this is a data. Another data that is given to the exhaust gas. Mass of the exhaust gas is 4.2 kg per hour. So here also we have to convert it into kg per minute, means 4.2 divided by 60 is equal to 0.7 kg per minute. Temperature rise of the gas delta Tg is equal to 220 degrees centigrade, that is given. Cp for water, specific heat for water, that is given 4.187 kilojoule per kgk, and Cp for gas is equal to 1 kilojoule per kgk. So this data from the problem that we have written, and we have converted the data into kg per minute regarding the mass of the fuel as well as the mass of the exhaust gases. So first calculation is heat equivalent in the fuel. The formula is mass of fuel multiplied its calorific value. So mass of fuel is 0.1 and calorific value of the fuel given in the problem is 44,000. So 44,000 kg per minute, that is the heat equivalent in the fuel. After that, heat converted in the brake power, means the formula is brake power multiplied by 60. So brake power is nothing but 18 and multiplied by 60 is nothing but we will get 1080 kg per minute. This is a heat converted into brake power. Heat carried by cooling water, the formula is mass of water then specific heat of water multiplied by temperature rise of the water. So 11.5 is the mass of water, 4.187 is the value for Cp for water, and temperature rise is given 25. So we after multiplication we get the value 1203.76 kg per minute. This is a heat carried by cooling water. Next calculation is heat in the exhaust gas. The formula is mass of the gas multiplied by specific heat of the gas multiplied by temperature rise of the gas. So mass of the gas is 0.7, specific heat of the gas is given 1, and temperature rise of the gas is nothing but 220 degrees centigrade. By multiplying all these factors, we will have 154 kg per minute. So this way we are having this fourth parameter, heat in the exhaust gas. After that, fifth calculation is heat lost as an unaccounted, means unaccounted heat is nothing but total heat is 4400 kg per minute minus 1080 is nothing but heat converted into power minus 1208.76 is the heat carried by cooling water, and 154 kg per minute is the heat in the exhaust gas. So by subtracting all these above mentioned four parameters, we can have unaccounted heat is nothing but 1962.24 kg per minute. If we put this in a heat balance sheet, then we can have the heat equivalent in the fuel on the left hand side 4400 kg per minute, and on the right hand side we are having how this heat is utilized. Heat converted into brake power is 1080 kg per minute, heat carried by cooling water is 1203.76 kg per minute, heat in the exhaust gas is 154 kg per minute, heat lost in unaccounted form is 1962.24 kg per minute. So total is again matching with the heat supplied, that is 4400 kilojoule per minute. So this way we have prepared here the heat balance sheet. Let us solve another example, and I am reading that numerical. During a trial of a single cylinder oil engine working on dual cycle, the following observations are made. Compression ratio is 15, oil consumption is 10.2 kg per hour, calorific value of the fuel is 43,890 kilojoule per kg, air consumption is 3.8 kg per minute, speed is 1900 rpm, torque on the brake drum is equal to 186 Newton meter, quantity of cooling water used is 15.5 kg per minute, temperature rise of cooling water is 36 degrees centigrade, exhaust gas temperature is 410 degrees centigrade, room temperature is equal to 20 degrees centigrade, and Cp for exhaust gas is 1.17 kilojoule per kg. After that, what has been asked here to calculate, number 1 is brake power. After that, brake specific fuel consumption and brake thermal efficiency. Along with, we have to draw the heat balance sheet on minute basis. So first parameter that we are going to calculate here, how the brake power is calculated. So we have to determine the brake power. We know that how to calculate the brake power. The formula for calculating the brake power is 2 pi nt upon 1000 into 60, where speed is n and that is given in the problem 1900 rpm, and by putting the value of this speed n is equal to 1900 rpm, we can calculate the brake power. Here 2 pi n means 1900 multiplied by torque, that is nothing but given 186 torque. So in the problem it is not if it is not given, then we have to assume that torque. So here torque is nothing but 186 divided by 1000 multiplied by 60, then we can have the value for brake power 37 kilowatt. After that, let us calculate brake specific fuel consumption, BSFC. The formula is BSFC is equal to mass of the fuel upon brake power. So here the oil consumption fuel is nothing but 10.2 kilojoule kg per hour. So 10.2 divided by brake power is 37 kilowatt, then 0.2756 kg per kilowatt hour. This is a value for BSFC. Third calculation is determining brake thermal efficiency. The formula is brake power upon mass of oil multiplied by its calorific value. Brake power is, we have already calculated. Mass of the fuel is nothing but oil. Mass of the oil 10.2 kg per hour. So brake thermal efficiency can be calculated here like this. 37 is the brake power. Then 10.2 is nothing but mass of the fuel. We have to convert it into second. That's why we have divided it 10.2 divided by 3600 multiplied by the calorific value of the fuel. So in this way, in this problem, brake thermal efficiency is calculated as 29.75% as in front of your screen. So let us see how to determine the heat balancing on minute basis. So here you will see again how much is the heat supplied, that we have to decide. Then how that heat supplied is utilized in the form of producing brake power, heat taken away by the cooling water, heat carried by the exhaust gases, and unaccounted heat. So let us see oil consumption, that is given 10.2 kg per hour. We have then calorific value of the fuel, that is given 43,890 kilojoule per kg. Then we have to calculate here heat supplied by the fuel. 10.2 is nothing but kg per hour of oil consumption divided by 60 multiplied by its calorific value. Then we can have a heat supplied by the fuel 7461 kilojoule per minute. After that, brake power is nothing but 2 pi nt upon 1000 into 60. We can have the brake power 37 kilowatt. Then heat equivalent to brake power means how much is the brake power? 37. So 37 multiplied by 60, then 2220 kilojoule per kg is the heat equivalent to of the brake power. Then heat carried away by the cooling water. The formula we are going to use here, quantity of cooling water used is mass of the fuel 15.5 kg per minute, specific heat of the water 4.187, temperature rise of the cooling water is 36 degrees centigrade. After that, we have to use the formula mass of the water multiplied by specific heat of the water multiplied by rise in temperature of the water. So 15.5 is the mass of the water multiplied by specific heat of the water is 4.187 multiplied by rise in temperature of the water is 36. Then we can have the value for heat carried away by the cooling water is 2332 kilojoule per minute. The next calculation is heat carried away by the exhaust gas. So exhaust gas temperature is nothing but 410 degrees centigrade. Room temperature is 20 degrees centigrade. Then Cp for the exhaust gas is given in the problem 1.17 kilojoule per kg K. Air consumption is 3.8 kg per minute. Oil consumption is 10.2 kg per hour. Then this formula that we have to use, mass of the gas multiplied by specific heat of the gas multiplied by rise in temperature of the gas. So mass of the fuel gas, so mass of the gas is 10.2 this is a fuel. 10.2 is nothing but the fuel mass of the fuel divided by 60 plus 3.8 is nothing but air consumption. So in this way we are adding here air consumption. Then specific heat of the gas is nothing but 1.17 that we have to add in this formula. Then rise in temperature of the gas is calculated as exhaust gas temperature is 410 degree minus room temperature is 20 degree. Then by putting all this value in this formula, we can have the value of heat carried away by exhaust gas is nothing but 1811 kilojoule per minute. Then by last calculation is heat unaccounted heat. So by difference, so total heat is 7461 minus 2220 is nothing but heat equivalent to break power. 2332 kilojoule per minute is nothing but heat carried away by the cooling water. 1811 is nothing but heat carried away by the exhaust gas. So all these parameters by difference can be calculated in the sheet, and it has been mentioned. So in this way, this heat balance sheet is prepared. In front of you, you will see that heat supplied by the fuel is 7461, and how the expenditure of heat is there in the form of break power, heat taken by the cooling water, heat carried by the exhaust gases, and unaccounted heat. If we add, again we are having the same thing, 7461 kilojoule of heat. So in this way, this is going to match, and heat balance sheet is prepared. I hope you understood how to prepare and how to solve the problem on heat balance sheet. Thank you very much. Again, I would like to request you all to subscribe my YouTube channel, Knowledge Link by myself, Dr. Ashish Vikhar. Thank you very much.